What up, athletes? Woo! Good morning. All right. So, we are going to continue day 2 of solving one-step equations. And today we're going to start off with solving one-step equations involving multiplication or division. You ready? Right here. Boom. Make sure, by the way, right now. Ooh, can I highlight? I don't know. How do I highlight? Add an annotation box, annotation circle. I don't know. Circle. Let's do a circle. Ooh. Let's do a green circle. See what happens. You guys ready for this? Let's check it out. Look at that. Boosh. All right. Solving one-step equations involving multiplication or division. Go ahead and make sure you have the LT, which is over that direction on the board in blue. And what is it today? I will solve one-step equations using multiplication and division. All right. So, as we look at this, I want you only, in fact, I'm going to kind of use this. I'm going to use that little highlight thing. Nope, that didn't work the same. It won't let me highlight these? All right. Well, then I'll just use this. I want you guys to just write down, number 1, multiplication property of equality, and then I want you to write down this information right here. For any real numbers a, b, and c, if a equals b, then a times c equals b times c. What does that mean? As long as I multiply both sides by the same number, they stay equal, because what's the rule? What I do to one side, you should be saying it in your head. I bet it's screaming in your brain. I do to the other, right? And how do we separate sides? Again, the equal sign separates the left from the right side. Okay, so just keep that in mind. And if x equals 3, then 8x equals 24. How does that help us? Well, let's find out. I'm going to have 8 times 3 equals 24. You know what I can separate 24 into? I can say 8 times 3 equals 8 times 3. Boom. So because of that, we're able to say the same thing. 24 is 8 times 3. They're both, we can break that down to 3 equals 3. They were both multiplied times the same number. All right, all we're saying is if x equals 3, I can multiply 8 times 3, and that's going to be 24. I could have gone the other route and said, hey, 24 equals 24. If I took the number 3 and multiplied it times 8, I probably did the same thing on the right side. So, whenever you multiply both sides by the same number, the equation stays equivalent. I could start off with 5 equals 5. Or how about 5 equals x? And then I'm going to multiply this side times 7. What's the rule? What I do to one side, I got to do the other. So I'm going to multiply this side times 7. And I get 7 times 5 is 35. So I know that 35 equals 7x. Okay? So that is an application of the multiplication property of equality. Now let's go ahead and move on. Let's delete that. I want you to write down division property of equality. It's going to have a similar deal. Write this down. Take a minute and do that. Again, pause it if you need to at any point in time. I know I kind of moved along with the last one, but always remember you can pause these videos. And what does it say? For any real numbers, a, b, and c again, c cannot equal 0. Why can c not equal 0? Well, we'll see in just a minute. If a equals b, then a divided by c equals b divided by c. The reason c can't equal 0 is you can never have division by 0. That doesn't work. You can't say, hey, here's a pizza, I'm going to split it up 0 ways. The answer is not 0, it's undefined. This is actually no bueno. It's a hole in math. It means undefined. You can never have division by 0. Undefined. Writing with a mouse is not the same. Oh, I'm getting there. I love one of them iPads, nice little pens, or maybe a Windows Surface. Anybody has an extra one lying around, feel free to drop it off. But that's undefined. We can't have that, so just keep that in mind. All right, and what's the example I gave? They say if x equals 35, then what are we going to do? We're going to divide both sides by 7. And if x equals negative 35, then x divided by 7 equals negative 35 divided by 7. Or what's negative 35 divided by 7? It's negative 5. Okay? We're just saying that if we divide both sides by the same number, boom, it still stays equivalent. Okay. All right, let's go ahead and go to the next slide. We don't have a lot to do today. But we do have some. I'm going to go ahead and move that up. Right there. Boom. Drink of my trusty coffee. It's morning today. I got up early in the morning to record this for you. I'm going to get my Canvas game going strong. For those of you that may be in QT or maybe you're just gone, absent for whatever reason, you can have a little something to look at to help you out. Or maybe you just need to look back this later, get a little refresher. 6t equals 78. Solve each equation and check your solution. Okay, if 6t equals 78, then what do I have? Let me remind you. I have 6. I'm going to break this down. 6t means 6 times t, right? And the way we would solve this is we could either look at it in our brain and say, all right, what times 6 is 78? I think it's going to be 13. And you could guess and check your way around it. Say 6 times 13. Let's try that. 6 times 3 is 18. Carry the 1. 6 times 1 plus 1 is 7. Oh, look, that's right. It is t equals 13. That's one way you could solve it. But sometimes these get harder. And what do? Well, how do we undo multiplication? What's the opposite of multiplication? It's division. And what's the rule? What I do to one side, I do to the other. What did I multiply times t? Because I want to get t by itself, which means I need to get rid of the 6. And since I'm multiplying times 6, I'm going to divide by 6. And when I divide by 6, 6 divided by 6 is 1, and I'm left with just t equals, what's 78 divided by 6? Well, 6 goes into 7 once, leaves a 1, 6, which makes this 18. 6 goes into 18 3 times. Boom! I have t equals 13. See how it did the same thing? All right. How about with this one right here? I'll give you a hint. Think of reciprocal. Ready, set, pause this, take a moment, see if you can solve it. Ready, set, go. All right. So we have 24 equals 4/3 d. I'm going to write this a little bigger over here. 24 equals 4 over 3d. Well, we talked about the identity property. The ultimate goal is to get this to be 1d, because then we can figure out what 1d equals, right? Or just d equals. So the way we have 4/3 and get rid of it is we multiply by the reciprocal, which is 3/4. So whenever you have a fraction times a variable, multiply times its reciprocal. And they'll cross-cancel everything, right? Everything cross-cancels to 1, and I'm left. Now, what's the rule? What I do to one side, got to do to the other. 3 over 4. Boom. Down here, I'm going to have equals, and I'm just left with d. Now, remember, we can always write 24 over 1. Why do we do that? To help us with our cross-canceling and understand. See, 4 goes into 4 once, 4 goes into 24 6 times. I'm just left with 3 times 6 up top, 1 times 1 on bottom, which can get ignored. What's 3 times 6? It's 18. So d equals 18. All right. Let's see if we're right. I like to get that check answer sometimes. So we're going to have 13 and 18. Let's see if we did it right. Check answer. Oh, that terrible yes noise, but I'm kind of getting partial to it. Awesome. Moving on. Kenji took a survey of the sophomore class. If 96 sophomores, or 2/3 of the class, said they were going to the football game on Saturday, how many sophomores were in the survey? Okay, well, let's talk about that. It says 96 sophomores, or 2/3 of the class. So that means 96 is equal to 2/3 of the class. Do we know how big the class is? No. What should we call that? How about we call it C? C is for class. And again, go ahead and solve this. What do we do to get rid of the fraction? Remember, reciprocal. Take a minute, pause this, work it out. Ready, set, go. And we're back. I'm going to multiply both sides times 3 halves. Yeah. 3 halves. And I told you I always like to put this over 1. 2 goes into 2 once. Goes into 96. Let's see. 45. 48 times. And I'm going to have 3 times 48. Let's see. 3 times 40 is 120. 3 times 8 is 24, right? Distribution. And we're going to add those together and get 144. Boom. So we get 144 equals C. And what would our answer be? The class has 144 students, or sophomores. So remember to write word answers for word problems as we go forward. But there we go. There's some good shown work. Awesome. Let's go. We're about done here today. Good times. Here's another word problem. I want you guys to try to set this up, see if you can get it done, and then we'll talk about it afterwards. So, ready, set, work it out. And we're back. All right. Stephen is saving to buy a new television. If he saved $1,400, so we know that he saved, where's my thing? Did I just turn this off? Oh, no, I didn't. Okay. Sorry, I thought I turned it off. That's funny. I couldn't find my little thing. All right, right here. I got it. All right. Oh, now I can't scroll up. There we go. I'm having issues here. So if he saved $1,400, right? $1,400 or 4/5 the cost. So that equals 4/5. And what am I going to use? What variable for cost? I'm going to use C again. Then what is the cost of the television? All right. I know I kind of have that covered up on my screen, but that's what it says. So again, we're going to use the reciprocal, 5/4. Use them fractions, they ain't going to hurt you. Some of you are like, yes, they are, Mr. Tim. No, they're not. 5/4. And boom, those cross out. I'm left with C equals, over here. Hey, if you're ever not sure how many times is 4 going to here, that's okay. We can try it out. 4 goes into 14 3 times. That leaves a leftover of 2. And it goes into 20. How many times? 5. Boom. And then just a 0. So 350. And what's 5 times 350? I don't know. 5 times 300 is 1,500. 5 times 50 is 250. So 1,750? Does that sound about right? Is that one of our answers? You bet your bottom dollar. Look at it right here on D. So let's see how we did. I say D. Check answer. Woo! We did it. All right, let's go to our last problem of the day. Before, I don't know what this is. Oh, we shouldn't have this on here. This is a help video. If you want to watch it, you're welcome to. We're not going to today because I got this awesome help video. So with that said, peace out.